Learning objectives. At the end of this topic, you will be able to cite the laws of chemical combination, discuss about an atom and molecule, write chemical formulae, describe molecular mass and mole concept. Introduction. Rani went to the kitchen to talk to her mother. How do you give 10 chocolates to your 5 friends?
I would divide 10 chocolates among 5 friends, that is 2 per each of them.
Around the same era, ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Right. The idea of divisibility of matter was considered long back in India around 500 BC. An Indian philosopher, Maharishi Kannad, postulated that if we go on dividing matter, padarth, we shall get smaller and smaller particles. Ultimately, a time will come when we shall come across the smallest particles beyond which further division will not be possible. He named these particles Parmanu. Around the same era, ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. Democritus called these indivisible particles atoms. All this was based on philosophical considerations, and not much experimental work to validate these ideas could be done till the 18th century. By the end of the 18th century, scientists recognized the difference between elements and compounds and naturally became interested in finding out how and why elements combine and what happens when they combine. Antoine L. Lavoisier laid the foundation of chemical sciences by establishing 2 important laws of chemical combination. Let me tell you more about this in this chapter. Laws of chemical combination. Laws of conservation of mass. Let's discuss the laws of chemical combination. Begin with law of conservation of mass with the help of an activity. Take copper sulfate, barium chloride, and lead nitrate as A, and sodium carbonate, sodium sulfate, and sodium chloride as B. Prepare separately a 5% solution of any one pair of substances under A and B in water. Take a little amount of solution of B in a conical flask and some solution of A in an ignition tube. Hang the ignition tube in the flask carefully. See that the solutions do not get mixed. Put a cork on the flask. Weigh the flask with its contents carefully. Now tilt and swirl the flask so that the solutions A and B get mixed. Weigh again. We can notice that mass of the flask and its contents do not change. Law of conservation of mass states that mass can be created, not destroyed, in a chemical reaction. Law of constant proportions. Lavoisier, along with other scientists, noted that many compounds were composed of 2 or more elements, and each such compound had the same elements in the same proportion, irrespective of where the compound came from or who prepared it. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Thus, if 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 14:3 by mass, whatever the method or the source from which it is obtained. This led to the law of constant proportions, which is also known as the law of definite proportions. This law was stated by Proust as, in a chemical substance, the elements are always present in definite proportions by mass. The next problem faced by scientists was to give appropriate explanations for these laws. British chemist John Dalton provided the basic theory about the nature of matter. Dalton picked up the idea of divisibility of matter, which was till then just a philosophy. He took the name atoms, as given by the Greeks, and said that the smallest particles of matter are atoms. His theory was based on the laws of chemical combination. Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportions. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. All matter is made up of very tiny particles called atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. What is an atom? Atoms are very small. They're smaller than anything that we can imagine or compare with. More than millions of atoms when stacked would make a layer barely as thick as a sheet of paper. Atomic radius is measured in nanometers. Let's view the relative sizes of various atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Through modern techniques, we can now produce magnified images of surfaces of elements showing atoms. What are the modern-day symbols of atoms of different elements? Dalton was the first scientist to use the symbols for elements in a very specific sense. When he used a symbol for an element, he also meant a definite quantity of that element, that is, one atom of that element. Berzelius suggested that the symbols of elements be made from one or two letters of the name of the element. In the beginning, the names of elements were derived from the name of the places where they were found for the first time. Nowadays, IUPAC approves names of elements. Many of the symbols are the first one or two letters of the element's name in English. The first letter of a symbol is always written as a capital letter, uppercase, and the second letter as a small letter, lowercase. Atomic mass. The most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. According to him, each element had a characteristic atomic mass. The theory could explain the law of constant proportions so well that scientists were prompted to measure the atomic mass of an atom. Since determining the mass of an individual atom was a relatively difficult task, relative atomic masses were determined using the laws of chemical combinations and the compounds formed. Let us take the example of a compound, carbon monoxide, CO, formed by carbon and oxygen. It was observed experimentally that 3 grams of carbon combines with 4 grams of oxygen to form CO. In other words, carbon combines with 4 by 3 times its mass of oxygen. Suppose we define the atomic mass unit as equal to the mass of one carbon atom, then we would assign carbon an atomic mass of 1.0 U and oxygen an atomic mass of 1.33 U. However, it's more convenient to have these numbers as whole numbers or as near to whole numbers as possible. While searching for various atomic mass units, scientists initially took 1 by 16 of the mass of an atom of naturally occurring oxygen as the unit. How do atoms exist? Atoms of most elements are not able to exist independently. Atoms form molecules and ions. These molecules or ions aggregate in large numbers to form the matter that we can see, feel, or touch. What is a molecule? A molecule is in general a group of 2 or more atoms that are chemically bonded together, that is, tightly held together by attractive forces. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. Molecules of element. The molecules of an element are constituted by the same type of atoms. Molecules of many elements such as argon Ar, helium He, etc. are made up of only one atom of that element. But this is not the case with most of the nonmetals. For example, a molecule of oxygen consists of 2 atoms of oxygen and hence it's known as a diatomic molecule, O2. If 3 atoms of oxygen unite into a molecule instead of the usual 2, we get ozone. The number of atoms constituting a molecule is known as its atomicity. Metals and some other elements, such as carbon, do not have a simple structure but consist of very large and indefinite number of atoms bonded together. Let's look at the atomicity of some nonmetals. Molecules of compounds. Atoms of different elements join together in definite proportions to form molecules of compounds. Let's discuss some examples. What is an ion? Compounds composed of metals and nonmetals contain charged species. The charged species are known as ions. An ion is a charged particle and can be negatively or positively charged. A negatively charged ion is called an anion, and a positively charged ion is called a cation. Let's take, for example, sodium chloride, NaCl. Its constituent particles are positively charged sodium ions, Na+, and negatively charged chloride ions, Cl-. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. A group of atoms carrying a charge is known as a polyatomic ion. Writing chemical formulae. The chemical formula of a compound is a symbolic representation of its composition. The chemical formulae of different compounds can be written easily. For this exercise, we need to learn the symbols and combining capacity of the elements. Valency denotes the combining power or capacity of an element. The combining power or the capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. The valency of the atom of an element can be thought of as hands or arms of that atom. Let's discuss the rules that follow while writing a chemical formula. They are as follows. The valencies or charges on the ion must balance when a compound consists of a metal and a nonmetal. The name or symbol of the metal is written first. For example, calcium oxide, CaO, sodium chloride, NaCl, iron sulfide, FeS, copper oxide, CuO, etc., where oxygen, chlorine, sulfur are nonmetals and are written on the right, whereas calcium, sodium, iron and copper are metals and are written on the left. In compounds formed with polyatomic ions, the ion is enclosed in a bracket before writing the number to indicate the ratio. In case the number of polyatomic ion is 1, the bracket is not required. For example, NaOH. Formula for simple compounds. The simplest compounds, which are made up of 2 different elements, are called binary compounds. While writing the chemical formulae for compounds, we write the constituent elements and their valencies as shown. Then we must cross over the valencies of the combining atoms. Molecular mass and mole concept. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. It's therefore the relative mass of a molecule expressed in atomic mass units. Formula unit mass. The formula unit mass of a substance is a sum of the atomic masses of all atoms in a formula unit of a compound. Formula unit mass is calculated in the same manner as we calculate the molecular mass. Mole concept. Take an example of the reaction of hydrogen and oxygen to form water. 2H2 plus O2 gives 2H2O. This reaction indicates that 1. 2 molecules of hydrogen combine with 1 molecule of oxygen to form 2 molecules of water. Or 2. 4 U of hydrogen molecules combine with 32 U of oxygen molecules to form 36 U of water molecules. We can infer from the above equation that the quantity of a substance can be characterized by its mass or the number of molecules. but a chemical reaction equation indicates directly the number of atoms or molecules taking part in the reaction. Therefore, it's more convenient to refer to the quantity of a substance in terms of the number of its molecules or atoms rather than its masses. So, a new unit, mole, was introduced. The number of particles present in 1 mole of any substance is fixed with a value of 6.022 into 10 to the power of 23. This number is called the Avogadro constant, named in honor of the Italian scientist Amedeo Avogadro. 1 mole is equal to 6.022 into 10 to the power of 23 in number, as 1 dozen is equal to 12 numbers. 1 gross is equal to 144 numbers. Besides being related to a number, a mole has one more advantage over a dozen or a gross. This advantage is that mass of 1 mole of a particular substance is also fixed. The mass of 1 mole of a substance is equal to its relative atomic or molecular mass in grams. The atomic mass of an element gives us the mass of one atom of that element in atomic mass units, U. To get the mass of 1 mole of an atom of that element, that is the molar mass, we have to have the same numerical value, but change the units from U to G. Molar mass of atoms is also known as gram atomic mass. For example, atomic mass of hydrogen is equal to 1 U. So, gram atomic mass of hydrogen is equal to 1 G. 1 U hydrogen has only 1 atom of hydrogen. 1 G of hydrogen has 1 mole atoms. That is 6.022 into 10 to the power of 23 atoms of hydrogen. Similarly, 16 U oxygen has only 1 atom of oxygen. 16 G oxygen has 1 mole atoms. That is 6.022 into 10 to the power of 23 atoms of oxygen. To find the gram molecular mass or molar mass of a molecule, we keep the numerical value the same as the molecular mass, but simply change the units from U to G. For example, as we've already calculated, molecular mass of water, H2O, is 18U. From here we understand 18U water has only 1 molecule of water. 18G water has 1 mole molecule of water. That is 6.022 into 10 to the power of 23 molecules of water. The word mole was introduced around 1896 by Wilhelm Oswald, who derived the term from the Latin word moles, meaning a heap or a pile. A substance may be considered as a heap of atoms or molecules. The unit mole was accepted in 1967 to provide a simple way of reporting a large number, the massive heap of atoms and molecules in a sample. Let's work out an example. Calculate the mass of the following. 0.25 mole of N2 gas, mass from the mole of molecule. 0.1 mole of N atoms, mass from mole of an atom. 2.011 into 10 to the power of 23 number of N atoms, mass from number. Solutions. 1. Mass is equal to molar mass into number of moles. M is equal to capital M into N. That's equal to 28 into 0.25. That's equal to 7 grams. 2. Mass is equal to molar mass into number of moles. M is equal to capital M into N. That's equal to 14 into 0.1. That's equal to 1.4 grams. 3. The number of moles. N is equal to given number of particles divided by the Avogadro number. That's equal to N by N naught. That's equal to 2.011 into 10 power 23 divided by 6.02210 into 10 power 23. M is equal to capital M into N. That's equal to 14 into 0.33. That's equal to 4.6 grams. Summary. Let's summarize the topic. Lavoisier noted that many compounds were composed of 2 or more elements. In a chemical substance, the elements are always present in definite proportions by mass. A molecule is in general a group of 2 or more atoms that are chemically bonded together. The molecules of an element are constituted by the same type of atoms.